The title of this note is Hyperbolas, and the outcome is to be able to graph a hyperbola that is centered on the origin or off the origin. So here's a picture of a hyperbola, and there are a few things that I want you to notice. So like an ellipse, it has a center, and it also has two foci. But this time, the graph is going away from the center. So here's the graph in black, and it's like two parabolas put together, and so they're each called branches. There's two branches to a hyperbola. The distance between the two vertices, which are right here, that is still it's still your major axis, but we actually call this the transverse axis. And then perpendicular to it, we have the conjugate axis. So we talk about this hyperbola being a horizontal hyperbola because the transverse axis is horizontal. So here is the key information about a hyperbola, and a couple of things that I want to draw to your attention. So in a hyperbola, the equation is actually going to look very similar to the equation for an ellipse. However, instead of a plus sign between the two terms, there's a minus sign. That's the first key difference. The other key difference I want you to notice is that this time, a squared, b squared, a squared, b squared, a squared is always first. So in an ellipse, a was always the larger denominator. That's no longer true. A squared is the first denominator. So then how do you tell whether or not you have a horizontal or a vertical hyperbola? You're going to look at your numerators. They're allowed to move around now. So a horizontal hyperbola starts with x squared, whereas a vertical hyperbola starts with y squared. Just like in an ellipse, we have this equation for our foci. And I want you to notice, for an ellipse, the equation was c squared equals a squared minus b squared. Now it's c squared equals a squared plus b squared. A hyperbola has two slant asymptotes that guide the branches, and so you need to know the slope of those asymptotes. And so you have these formulas here, but I'm going to tell you I'm not really good at memorizing those formulas. What I do know is that slope is rise over run, and rise is the change in the y and run is the change in the x. And so I'm going to look at the y denominator. That's my rise. So over here for the horizontal, it's b is the rise, a is the run. Whereas in the vertical, a is the rise, b is the run. Right, we said we no longer call it the major axis. It's now the transverse axis. It's double the length of a. And we see a couple of graphs. So for your horizontal hyperbola, your branches are going off to the right and the left. And for your vertical hyperbola, your branches are going up to the top and the bottom. Okay, so how do we actually make a graph? So the steps are going to be a little bit different. So for graphing hyperbola, we're going to start with graphing the center. And then you're going to sketch your two asymptotes using your slope, rise over run. And then after you have your asymptotes, you're going to sketch just your vertices. You do not need your co-vertices anymore. And once you have your vertices, you're just going to draw your two branches of the hyperbola, passing through the vertices and guided by those two asymptotes. So let's look at one together. Okay, so we're going to graph the hyperbola y squared over 1 minus x squared over 4 equals 1. So the first thing I want to do is I want to graph the center of this. So it's centered at the origin, 0, 0. And I can tell that this is going to be a vertical hyperbola because it starts with y. So my hyperbola will end up going up and down, a vertical hyperbola. So step 2 is to graph the asymptotes. Now the slope of the asymptotes is rise over run. Rise is the y direction, so the rise is 1. Run is the x direction. It's 2 because this is 4. which is actually 2 squared. 1 is 1 squared, but 4 is 2 squared. So the b value here is 2. So we have a slope of 1/2. So that means my asymptote is going to go up 1 over 2, and I'm going to draw a dashed line to represent my asymptote. My asymptote is also going to go in the other direction, so my slope can be positive or negative 1/2. So it'll also go up 1, left 2. And there are my two asymptotes. All right, so then the next part is the, oops, I was trying to move that. The next part is the vertices. And the vertices are in the y direction because this thing is vertical, and they are 1 unit away from the center. So 1 unit away from the center in both vertical directions are the vertices. And then the last piece of that is to actually draw your branches, and they hug those asymptotes. And there you go. There's your hyperbola. So that was a hyperbola centered at the origin. We're going to do one more example together. This time the hyperbola is not centered at the origin. So first things first, what's the center? Remember, everything in the parentheses is backwards. So the x-coordinate, I'm going to look here for the x-coordinate, is actually +1, and the y-coordinate is +2. So I'm going to go to my graph, and I'm going to find +1, +2. That's the center of this hyperbola. Now I want my slope for the asymptotes, and it's rise over run. Rise is in the y direction, so the rise is 4. The run is in the x direction. So from this center point, I'm going to go up 4 over 3. I can tell I need to extend my graph. Oops. Let me move there. There we go. So extend my graph. Okay. So from the center, I'm going to go up 4 over 3. 1, 2, 3, 4. 1, 2, 3, right there. You can also go in the other direction, down and left. Get a couple more points. There's the asymptote. Asymptote also goes with negative slope. So I'm going to do the same thing, but with a negative slope. Connect those with a dashed line. All right, so those are the asymptotes that will guide the hyperbola. And now I need to find the vertices. The vertices are on the vertical because it's a vertical hyperbola. And so in the vertical direction, I need to be 4 away from the center. So I'm going to go 4 above the center and 4 below the center. Draw the vertices. And then I'm going to draw my branches guided by those asymptotes. They're going to hug those asymptotes. And that's a graph of this hyperbola. That's it for our notes. Go ahead and draw your line and bring your notes into class.